Hello and welcome to another demo from Portworx. In this demo, we'll be talking about how you can leverage Portworx PX-DR to build a zero RPO or recovery point objective solution for your Amazon EKS clusters. Zero RPO is important when enterprises can't afford any data loss when an EKS cluster goes down. PX-DR helps you deploy a Portworx cluster that is stretched across two different EKS clusters, and as long as they can meet the 10 millisecond latency requirement, they can be as far or as close to each other as possible. This is important if your EKS cluster for any reason goes offline, you can quickly log into the secondary cluster and bring your applications back online as soon as possible. In this demo, we have two EKS clusters running in the US East 1 region and a simple pet clinic application running on top of our primary cluster. We look at how we can create a cluster pair object between the two EKS clusters and then perform migrations according to a schedule policy so that any data that's written on our primary site is automatically copied to our secondary site before the write is acknowledged, and all the different Kubernetes objects like pods, deployment, service objects are copied at a scheduled interval. We'll simulate a failure and then log into our secondary cluster and bring our applications online. So let's get started. Here we have a primary cluster on the left and a secondary cluster on the right. Let's do kubectl get nodes on both the clusters and look at the clusters that we have. We have a 1 master, 3 worker node set up on each EKS cluster. If we log in or SSH into the first worker node on our primary cluster, we can run pixie-cuttle status command, which shows us all the different nodes that participate in our Portworx storage cluster. As you can see, this is a stretched Portworx cluster, so worker nodes from both the EKS clusters are contributing storage to our Portworx storage cluster. If we exit out of our worker node, we can run additional commands like kubectl get all to look at the application or demo application that we have running. It's a simple pet clinic application with a couple of deployment and pods and a couple of service objects. We also have one persistent volume called pet clinic db mysql, which is bound to our pet clinic db mysql pod. The service pet clinic is hosted as a node port service, so we can access it using any one of our worker node or master or control plane IP :30333, which is our port number. So let's navigate to it and make sure that our application is up and running. So here we have a few entries already. So if you look at the veterinarian's doctor section, you'll see a few vets already defined in the system. If you look at the owners, we have a few owners with their individual pets registered. We can also find a specific owner. So Jeff Black is one of the owners who has Lucky, which is a bird that's stored in our MySQL database. So now let's look at PX-DR and the different configuration parameters that we have configured for this sync-DR or metro-DR configuration. If we do a kubectl get cluster pair in the kube system namespace, you will see the remote cluster -2 object that exists between our primary and secondary cluster. If we do a stork-ctl get migration schedule in the same namespace, you can see our app migration schedule, which is our migration schedule defined for our demo application. It uses our cluster pair remote cluster 2 and relies on a policy, a schedule policy called app schedule. Right now it's active, the suspend flag is set to false, and the last run was successful 20 seconds ago. We can monitor individual migrations that get kicked off as part of the schedule. So you can see that there is a current active migration in progress. The last one was successful and it copied 6 objects from our primary to the secondary cluster. We can also do a kubectl describe of the schedule policy app schedule and look at our interval minutes. So any data that's written on the primary side is definitely copied on the secondary side, but all the Kubernetes objects and application configuration is also copied from the primary to the secondary cluster every 2 minutes. So that's something that you can configure as part of your own schedule policy. Now let's do a kubectl get all command and look at our pods and deployments. Again, we can do a stork-ctl edit migration schedule. So now we are at a point where we want to simulate a failure. So we'll basically stop our migration schedule, and then once the migration schedule is is suspended, we'll scale down our application on the primary side, and then on the secondary side we'll basically activate the migration. This is important and an additional step because we are not actually going through a disaster event, we are trying to simulate a disaster event. So that's why we have to disable the migration schedule. If there was an actual disaster event, you won't have access to your primary cluster, and then all you need to do is go ahead and on your secondary cluster and activate that migration. So let's continue with the simulation. So we'll scale down our deployment for both the pet clinic DB MySQL and set the replica count to 0, and then do the same thing for our pet clinic deployment object as well. So now our pods will start terminating from a running state. So this is where we experience that disaster event. We'll wait for the pods to be completely turned off before we log into the secondary cluster and activate our migration and try to bring our application online. While the pods are getting terminated, we can log into the secondary side, do a stork-ctl get cluster domain status. As you can see right now, both are in sync. No new data has been written. And then in a few, as soon as our pods are down, which they are, we'll go ahead and basically deactivate our primary cluster domain. If you look at kubectl get all, you'll see the service and deployment objects already exist on the secondary side, but unless you activate the migration, no application pods will be spun up. We can do a stork-ctl deactivate cluster domain, if I can type correctly, cluster 1. So this basically removes the trust relationship or deactivates our primary side. So we can do clear and then do a stork-ctl get cluster domain status again. And you can see that our cluster 2 is our local domain. That's the active side. Cluster 1 is not in sync and nothing is happening there. So if we do a stork-ctl activate migrations, PX-DR knows the number of replicas that you had configured on your primary side. So it basically scales up your deployment objects with that replica count, and our pods start spinning up. So it goes from container creating to pod initializing to running phase. So once we wait for both of our pods to come online, what we can do is we can go ahead and navigate to the pet clinic front end and verify that all of our vets and all of our pet owners are listed in the database as well. So let's do a kubectl get all. The service object still uses the 30333 port. Both of our pods are up and running. If we try to access the primary side, that's unavailable right now. So let's go ahead and find the IP address for my master 2. And we'll go to the browser again and then try to navigate to master2:30333 to verify that our application is back online. If you're doing this in production, you should have a load balancer instance sitting in front. So if your primary side goes down, the load balancer can automatically forward traffic to the secondary side. As you can see, all of our records in our pet clinic application are as is. There has been no data loss. And basically this is the same process you can use for any application that's running on your AWS EKS cluster and achieve an RPO of 0. That's it for this demo. Thanks for watching.